Okay guys, so this is an example of a one-way Anova with three conditions in a repeated measures design. So this is where the same participants attend all three conditions. Now these scores are depression scores. The higher the number indicates the greater level of depression. And there are three conditions: a control condition, a 5-minute mindfulness condition, and a 3-week more intensive mindfulness condition. These are post-depression scores. If this was a real experiment, what we would do, we would have pre-scores and post-scores and then compare the two. But that would be a 2x3 Anova, which I'll cover in a different session. As I'm trying to demonstrate a simple one-way Anova, we're just using post scores. Now, I've got the labels in. Utilize the previous videos to work out how to do that. You might want to put in labels here. So control, remember this has to be a single word, 5 min mind. So just put 5 minutes. And then you want to have something like 3 weeks. Just to indicate, what these actually are, if that doesn't make sense to you at a later date. And that's it. Go back to your variable view. Now we have to perform a Shapiro-Wilks test on all our data. I already added these in. It's very, very simple. You'll have them there. Cross them over to that. Look at your plots. Make sure your histogram is checked. Make sure your normality plots are checked. Histogram, you can just visualize it in a series of bar charts just to see whether it's roughly normally distributed. And normality plots will tell you whether you can utilize the parametric test, i.e. the Anova, due to the fact this is normally distributed. So click continue, click OK, and takes a second. Most important thing is this first box here. If you look at the histograms, they are pretty messy. You might say that's a big skew there, that's a big skew there, but it's a very small sample size. And this is, the test is telling me this is significant enough. It's only borderline significant. So as long as it's above 0.05, then this is significant. So though it's, you visualize it and you'd say, okay, that's probably not a normal distribution, it's not a normal bell curve, it's still significant enough, so we can still utilize, as long as that's over 0.05, that's all that matters. Similarly with the other, this is 3 weeks, again, look at that. So pretty messy data, maybe this is a little bit neater, but yeah, see the third one's a bit neater, but they're still over 0.05, so that's all that matters. Now I'm going to perform the actual test now. So go into Analyze, and you want to go into Repeated Measures Tests. So you select General Linear Model, and then select the Repeated Measures Test. I've already put in factor. So what you want to do, you want to have a within group variable name, something like condition. And you want to have 3 levels. Add that in. Then you have to define them. So right now it's just telling SPSS there are 1, 2, 3 conditions in this model. Now define it, and you need to select these and pass them over. 3 weeks. You might want to look at things like options, condition into display means. You want to do a Bonferroni check, which will basically check in between the significance between control, 5 minutes, 5 minutes, 3 weeks. So it tells you the significance between these and these. The overall Anova will tell you the significance between the entire model. So that means, is there a significant difference between these in general? And then the Bonferroni, which I located in options, will tell you is where the significant lies. There might be a case that there's a massive significance between these two, but no significance between these two. Looking at the data, I kind of constructed this made-up data in a way to make sure there was large differences between each column. So we should find differences between all of them. but that's what the Bonferroni is basically doing. You can add things like descriptive statistics, estimates for effect size, which will tell you the effect size. We're not going to go into that in this particular session, but I will cover that in more detail. And then you want to look at observed power. So this tells you the actual power given your sample size and the differences between those. It's an important thing. Again, I'll cover that in more detail in another session. Click OK, click Continue. And what you get is you get this sphericity assumed statistic. If this is non-significant, that's a good thing. You can use the sphericity assumed if that's non-significant. In this case, it is. If it wasn't significant, go to the Greenhouse-Geisser check. But this is a non-significant finding. So you can utilize the sphericity assumed column. So use this here. You can see your significance is 0.000. That means below 0.05. Your partial eta squared is huge. It's 0.98. That's a huge effect there. Your observed power is 1. Again, that's a huge effect size. That's 100% effect. So it's a large effect. That's because I constructed the data in a way that would create a large effect size. Other factors are important. Your degrees of freedom. All the degrees of freedom is saying is how many groups do you have minus 1. So how many groups are free to vary. So all that means is you've got 3 separate groups minus 1, and your degrees of freedom in this case is 2. Again, I'll go into that in more detail in another session. So in statistics is the kind of thing you just got to state your F value. This is an F test, so always state this. It's an F test, F, and then in brackets your degrees of freedom is 2, equals this number here, and then comma, P is smaller than 0.05 with eta squared of 0.99 to 2 dp. So that's that. The other thing then we want to look at are these pairwise comparisons. These are the Bonferroni checks, and if you look at 1 to 2, so this means this condition versus this condition, it's very, very significant. 1 and 3, so that's control, versus 3 week, again, it's very, very significant. It might have been the case, I could have constructed this data in a way, like I said, where there was no, these are all 80s, maybe these are all 70s. If I did that, 1 to 2 would not be significant. So the overall model significance might have been there in this one here. So this column here, this still might have been significant, even though this and this were very, very similar, but this one was very different. So maybe these are in the 20s, but these are in the 80s, and these are in the 70s. So there's very little difference between these, but a massive difference between these two and the 3rd week. This statistic might still be significant because it's checking the significance of the overall model. When we get to the pairwise comparisons, again, it's telling us where the significance lies between the different conditions. And as you can see, 1 to 2, that's significant. 1 to 3, so 1 to 2. These two are very, very significant. 1 to 3 is very, very significant, so control. And 3 week is very significant. And I guess we have to check 3 to 1, which is also very significant. So, sorry, 3 to 2. 3 to 2 is that. So between these two, it's also very significant. And that's it. So you can, once you've reported your F, DF, and then the score, and then your significance, the partial eta squared, you can then move over to the pairwise comparison and identify between groups 1 and 2, it was significant, between groups 1 and 3 it was very significant, and between groups 2 and 3 it was also very significant. And that's it. I'll cover a session on in terms of proper kind of APA notation in terms of writing this, but that's a one-way Anova repeated measures design in a nutshell. Okay guys, so thank you very much, and I hope that was good for you.